Good morning. This morning I'm talking about physics, so if this doesn't interest you, I certainly understand. You might want to skip this video, but if it does, then great. I have some wonderful imaginary friends coming in this morning. We're going to have a cup of coffee together. Oh, hang on a second. There he is right now. Good morning, Nicola. Come on in. Yeah, great to see you. Little hug for Scott. Great. Here you go. Does that work all right for you? Good. I'm not going to mic you up, and I won't put you on camera like you asked. Nicola is very shy, and he doesn't want to be on camera, which is understandable because he's been dead for a long time. But here he is nonetheless. So what an opportunity, huh? Nicola, there's been some discussion lately about the speed of light. I know that you have great interest in this, and I know that it's a discussion that you had some very long time ago. A guy named, and I'll try and pronounce this correctly, Joao Meguijo, Imperial College London, feels that the speed of light is slowing over time. He feels that at the Big Bang, the speed of light was near infinite. It slowed down to 3/4 magnitude faster, and then, of course, to 299,790 to 458 meters per second, which is where it is right now. We think 186,000 miles per second. 671 million miles per hour. We can see out into space for 47 billion light years. That's the horizon, and we don't know what's beyond that. We theorize that it all had a singularity and that it expanded from that singularity. We don't know that. That's what we think. This Meguijo article was in the Physics Journal in November, and it was a discussion of the slowing of the speed of light, if you have an interest in that. Nicola, since you're here, it gives me a great opportunity to talk to you about your thoughts about transmission of light through space and my thoughts about the transmission of light through space. Yes, yeah. Nicola says that he feels that light is transmitted through space, through the ether of space, as do I. But in the initial theory of relativity that Einstein developed in the patent office in Zurich, that he kept in his left drawer, that's a magnificent document and a great step forward for mankind, and one of the many great things that Albert did. He felt that he needed to abandon the ether of space, not because he disagreed with its existence, but because he could not calculate nor sense it. So that's important because science now has abandoned the theory of the ethers of space. Nicola and myself have not. We both feel strongly that it exists. We feel that it can be somewhat defined. And we feel, and correct me, Nicola, if I'm speaking for you here a little bit, but you didn't want to be mic'd up. You don't want to be on camera. So I'll take a shot. You please speak up if I say something out of line, okay? All right, bud. You want some more coffee? You good? Okay. Yeah. Here's how I see it. Now, as with many things in physics, you have to have kind of an open mind here, because this is not a two-dimensional square problem, nor is it a three-dimensional problem. Space is full of waves. Yeah, Nikola did a lot of work with this, and Nikola, not to blow your horn for you, Nikola, but Nikola saw things that no one else saw long before anyone else saw them. Much of what he believed has come to pass as true in a world that rejected much of what he believed at the time when he believed it, before any of the rest of us. Again, Einstein and Tesla, two minds beyond the world. And when you consider the knowledge base that existed at the point of their living, incredible what they saw. Here is how I see the ether of space. And if you're thinking to yourself, this is an oversimplification, it most certainly is. It most certainly is an oversimplification. But we have to learn to discuss things in simple terms. And we have to learn to discuss things analytically. As a frustration that I think I share with you, Nikola, he says, yes, absolutely. Mathematics are not the answer. Mathematics are a part of the experiment. The scientific method requires that a hypothesis be developed first, and then the hypothesis is tested. Part of that test can be a mathematical test of the hypothesis. Your criticism of Albert, who has great respect for you and who I know you have great respect for. Yes, yeah, he says he's a great man and the greatest mathematician that ever lived, and I agree completely. Absolutely, he is. But because he's a mathematician, that's where he stands. And that's okay, but we have to recognize that Albert Einstein, brilliant man, greatest mathematician that ever lived, in my opinion, in Tesla's opinion. Of course, he hasn't known the recent ones, nor do I really. But when he looks to solve a problem, he uses mathematics. And all problems are not solvable by mathematics. They're just not. This may be one of those problems. In order to develop the theory of relativity and the special theory of relativity, he made some assumptions. They're very large assumptions. One of those was the speed of light. E equals mc squared. Energy equals mass times the speed of light times the speed of light. That's a huge number, the speed of light. 299,792,458 meters per second. I've got it written down here so I can give it to you exactly. But it is not exact. In fact, we can slow the speed of light. We can stop the speed of light. The speed of light is bent, refracted within a lens, so that the thinner lens at the outside slows the light less than the thicker lens at the inside, or vice versa. So light can be changed. It can be bent through materials that transmit it more slowly. Since light appears to have a constant speed, and Nikola, I'm throwing this out, so you'll have to tell me if you think I'm getting out base. But since it appears, and Albert dealt with this, to have a constant speed, then it makes sense that there's something keeping it at a constant speed. If I'm flying along in a spaceship and I'm almost going the speed of light, and I roll the window down and stick my hand out with a flashlight and turn it on, the light from that flashlight should be leaving me at the speed of light. And yet Albert theorizes that it is not. In fact, the light from the flashlight's barely moving, moving up to the speed of light but not exceeding it. And someone in front of me, with me coming at them at just nearly the speed of light, with that flashlight on, won't see me or the flashlight. Now that's incomprehensible to the average Joe on the street because it doesn't make sense. I know that if I'm in a car and I throw a baseball at a child in a crosswalk, shouldn't do that, but sometimes I do, then the ball goes faster than the car. And that makes sense to me. And it should. I've got some Einstein hair going on here. That makes me think better. But light's not like that. From what we can tell, it only moves at a given speed in a vacuum, and many other parameters. And that, in fact, as I discussed earlier, is being rethought now. Maybe it's changing. Maybe light is slowing. Many things are proven, and many things are theorized. We need to segregate the proven from the theorized, and then we need to develop hypotheses based only on the proven. We can theorize. We can build upon theory that exists, and that is a good thing to do. But we cannot accept theory as proven reality, or we'll go wrong. And we have gone wrong many times, and that's all right. Here's how I see the ether. And let me know, Nicola, because you spoke about it often. We say, and the double slit experiment shows us, that light travels as a wave through space. And yet, we can see the photons. We know that they're there. The photon exchange was once thought of as a broadcast, like shooting these photons from a gun. And when you turned on your light, these photons were being fired out, mass going through space. But in fact, we proved from the double slit experiment long ago that they act as a wave. And this has puzzled people for a long time. And it's a very simple concept. When I look at a wave in an ocean, of course, that's a one-dimensional wave. I don't look at the water molecule. I look at the wave. When I look at a wave of light, or EMF, in any of its frequencies, I see the photon, but it is not the photon that creates the wave. The wave exists within a medium, and that is Nicola's ether. I see the ether of space like this. I believe it's matter. To understand these concepts, you must look at everything as a cloud, and it is. So I've got my t-shirt on. I am made up of atoms. And these atoms have very little mass, extremely little mass. If a hydrogen atom, let's take for instance, one electron, one proton. If that proton is this big, the size of a blueberry, the electron will orbit it in an arena in that orbit the size of a stadium. There is one electron and one proton, and all else is empty space. They're held in association with each other with the weak bond, and the nuclei of these various atoms are held together with a strong bond. That's unimportant right now. But we have to think of light transmission through space. We have to think of the transmission of gravity through space. We have to think of the transmission of all the other things, X-rays, radio waves, all of this array, which Nikola dealt with so brilliantly a long time ago. We have to think of this moving in different frequencies in all different directions through space. But space is not space, as I am not a solid. You could take all of me and take out the emptiness, and the mass would be smaller than a tiny grain of sand. There's no mass to us. And that's why X-rays move right through us. That's why so many of these things move through us. I believe this. I believe moving through us also is the matrix of space itself, Nikolai's ether. And he concurs. Imagine, if you will, a new atom. And I don't know that it's different. I don't know if it has electrons and protons and neutrons, or if it does not. I know that it's not detected, so perhaps that arm of the blueberry to the stadium is greater, maybe far greater. We don't know. But we do know that spaceships traveling through true space build up static charges. And that is very material, because that tells us that they must be impacting something out there that has a charge. And indeed, I believe they are. So here, within this matrix, is this, and that's going to be hard for you to see, but imagine this arm. So here this matrix is filled. I hope you can see my little circle with the dot in the middle there. That's just indicative of this ether atom, if you want to call it that. And of course, they fill each space. They find equilibrium electrically, as does everything that we're aware of. And they seek to become at equilibrium, as does everything in our physical universe that we're aware of. Therefore, this matrix exists. There were some experiments done long ago to try to find the ether of space, and mirrors were floated on wooden floats in a pool of mercury, and light was reflected from those mirrors out and back, and the difference in the time of the reflection was measured as best could be done, and it was decided that there could be no ether. Basically, the differences in the time were within the error of measurement, and the differences in time are still within the error of measurement. One would assume that the ether of space is moving relative to the Earth. It would be odd if it were not. Yet it may barely be moving relative to the Earth. In actuality, I am quite sure that the reasons that the experiment failed were a failure of understanding, and not a failure of the mathematics nor of the experiment. This entirety of this matrix allows an exchange, and the exchange are photons. Now, those photons may be carried in the nuclei, or they may be carried out here. I don't know. But when a wave of photons is pushed into this area or this area, central to or outside of the orbits of the outermost atoms, if indeed they're atoms, if indeed they're negatively charged, things we don't know, then that would cause some of these to surrender their place to here, which would then cause some of these to surrender their place to here, which would then cause some of these to surrender their place to here, and that is our wave. That is our wave. Now, to make this infinitely more difficult, this is in all dimensions, so that this can be coming this way or this way or this way or this way. It doesn't matter. It can be in all dimensions, and that makes it extremely difficult to comprehend. Nikola says that he doesn't know that it's like that, but he thinks that it exists, and he knows that it is there because if it was not there, we would not see light. We wouldn't know there were stars in our sky. I agree, Nikola, and I have no idea either what causes it to act, and I have no idea what its elements are. I suppose that because the atomic structure makes sense, and it's the atomic structure that all mass that we're aware of is composed of. Now, the photon is a tiny, tiny, tiny particle, even on atomic scales. Let's talk about transmission of gravity, because it's one of the difficult things. Anything which has mass attracts anything else that has mass in space. And as is true with the dispersion of light, gravity its attraction is reduced by the power of the square of the distance between the objects. Light intensity is reduced by the power of the square of the distance from its source. It's coincidental, it's basic mathematics, but it is vitally important because there's a physical base to that mathematical issue. And the physical base may be the same because the math is the same, don't you think? That supports this hypothesis. Because this is a very simple explanation that allows for the proven mathematics of gravity and light. So let's look at the Earth, and let's look at what happens around the Earth, or any massive entity, the sun, for instance. Einstein theorized that space was bent by mass. He imagined space, he showed it in a planar fashion, and it was indented where there was mass. I've always had a hard time with that, and I've never felt good about it. Here's my explanation. If we have a planet and we have this matrix of space, the ether of space, as my friend Nikola called it. We have a planet, or it can be a sun. It doesn't matter what it is. We have mass. It can be a black hole. Here it is. And we have this ether of space, which has mass. And it is at equilibrium. Imagine, if you will, it rushing into this mass. Imagine the components of this rushing in to fill space to maintain the velocities of the electrons around the nucleus within this mass. Then all of this would be collapsing constantly into these masses. Boom. Since there is some resistance to the passage electrically of mass through mass, when an X-ray goes through you, it knocks you back just a little bit. As these are drawn into the Earth, the Moon, the Sun, the black hole, they produce gravity by passing through us, by passing through this chair, by passing through my friend Nicola. Actually, not so much, because he's a ghost. So I don't know. Do you suppose it? He says it does act on ghosts. So otherwise, he'd be floating around the room, and he is not. He's sitting in a chair right there. I would show him, but he declined to be shown on camera. There's another experiment that also lends itself to this theory. And that is an experiment where a great magnetism, a chamber is developed, and this has been done a million times, and it has a little port in it, and there is a huge magnetic field applied. And then there's a little frog in here. I'll try and draw a frog. I'm not a very good frog drawer. That's a frog. That is a frog. Okay. It's kind of a malformed frog, but a frog nonetheless. This frog floats as if unaffected by gravity in a very strong magnetic field. You need to make that make sense, and it doesn't make sense. It makes sense if I am right, and these rushing vortexes, and I shouldn't call them vortexes, if this rushing gaseous mass of the ether is collapsing into our world, and this frog is on the surface of it, it holds him down. But if you can pull the ether space apart with magnetism, then the frog is no longer influenced by gravity. So that is as important as is the double slit to understanding gravity, which is the great unanswered question, in my opinion. So that is my opinion with my friend Nicola, and you'll be happy to hear Albert's coming by, so I'm going to talk to him too like this, and it'll be nice. I have great admiration for Albert. Nicola says the same. He feels great admiration for him too. And I'd like to bounce this off of him and also talk to him about some of the things that have changed in theory since his theory of relativity and his theory of special relativity, and what people are thinking now, and get his reaction to that. Do you have anything to add, Nicola? Nicola says, keep an open mind. And Nicola also says, as he said before, mathematics are not science. Science is wonder and testing that wonder. And mathematics are the test. We have respect for mathematics, and they are valid because they're an absolute. Until we start injecting non-mathematics in the form of the square root of negative numbers and things, where we're finding an answer to a problem rather than testing a hypothesis under the scientific method. Got anything else? Nothing. Nothing. He has nothing to add. Have a great day. If you spent 30 minutes listening to this, I hope it opens your mind. And if you're into physics as I am, I hope that you got something out of it, and at least that it made you think a bit about the entirety of this thing. I feel very strongly, and always have, that there is a medium to transmit things through space. I think it's self-evident, as did Nikola Tesla, as did many others. Albert, I think, will attest when he comes by that it was not his intent to ignore the ether of space, which is what we've done. It was his intent to not consider it for the sake of testing a hypothesis, and that was valid. Thanks so much. I'm sorry it took so long.